is to show how to get to things like the syllabus and the course webpage through Canvas, because y'all can access Canvas definitely. So most of what I do is through a public-facing course webpage, which just as a webpage looks something like that. There's some stuff at top, and as you scroll down, a day-by-day schedule with what's happening each day. Let's focus on the syllabus first. And you don't need to go through Canvas to get to that webpage. Right? It's publicly accessible. In fact, if you just like Google my name with UWEC, you'll find my parcel webpage, and then from there you can get there. Anyone want a paper syllabus? Cool. Okay. I want to point out a few things in particular. I'll have regular drop-in office hours 4 times a week. They are Monday, Wednesday, Friday, 1 p.m., Thursdays at 10 a.m. And those are times when you don't need to make an appointment to come see me. Any of your professor's office hours, those are times that they've already set aside to talk to you. So just come by to talk to whatever professor during their designated office hours. You can also come talk to me whenever. I just might be busy or not in my office. If you just try. You can also try to schedule appointments. There's the course webpage, but we've seen that. Anyone bring their textbook with them today? You want to take it out and just hold it up? I just need one of you. Cool, there's one. Just hold it up. Cool, perfect. That's the one I think it is. Has anyone not managed to get a copy from the bookstore yet? Okay, I'm sure it's there though, right? Okay. No one has tried and failed to. Excellent. Here's an observation. The textbook's kind of heavy, right? I don't expect you to like lug it with you to class. Save your back. That being said, there will be some recommended bums and suggested readings that I'll suggest out of it. There might be a few days when I do want you to have it on you, but I'll let you know in advance. Textbook, you know the meeting time because you're here. Most of these are just dates that you can get to through the university webpage. September 10 is the last day to add a class. In fact, so here's a question. So how many people took like college algebra or equivalent in a previous term? So a lot of what we'll do in this class, basically the first half of this class, will feel very much like a review of what happened in college algebra. If you felt comfortable with that, then another path that gets you to calculus is a class called trigonometry, which is a 2-credit-hour half-semester course. If you feel that would fit you better, take a look. September 17 is the last day to drop without a W. Last day to change to a pass-fail grade. Ooh, is that like a loss on there? I think it is. September 24 is a math department deadline only. If you feel like you want to drop down to the pre-req class to this class, so that would be college algebra, that's the deadline to do so. If you get to about that point and you feel like you could use something a little bit more relaxed in pace, go talk to the people in the math department office. It's up on the 5th floor. November 12th, last day to drop with a W. We'll talk about like the content soon. I just want to do logistical things. So there's the breakdown of grades by grade item. So I'll assign semi-regular open-ended homeworks. I think mostly about 2 of them per week. There'll be a single question that I'll have you answer. The goal in those open-ended homeworks is to have you really explain the ideas. I don't care if you get the right answer. I care if you can explain the ideas that got you to the right answer. If at some point during the walk you accidentally add 2 and 2 and get 17, yeah. I won't be happy, but if you clearly explain the ideas, I'll be mostly happy. There will be basically every day assigned a collection of WebWalk homeworks. So these are automatically graded homework problems. They're accessible through Canvas. The way I have them set it up is you have an unlimited number of attempts on any one of those problems. The goal is you can use them to see if you're understanding the ideas. If there's a problem that you keep on attempting and you keep getting it wrong, maybe just talk to me about it. Some of the problems are written by me, so some of them have errors in them. If you suspect that you're on one of them that has something goofy going on, come talk to me. There'll be like a low weight background material quiz that'll happen in a few weeks. We'll go through the schedule in a moment. There will be some midterms and a final exam. There will also be a whole ton of extra credit posted as the class progresses. In that, I think if you do like all of the extra credits in this class, you can probably net like 15 percentage points of extra credit, which is absurd. It's not built into the class plan that anyone's going to do that. Chances are if you're going to put in the work to do 15 extra credit problems, you already have a day. They're intended to be interesting problems with the extra credit being a little extra bonus to get you to look at them. All right, open-ended homeworks. Deadlines will generally be Friday. You always have at least a week to do any of the open-endeds. Once I start grading, which will usually be like the weekend after that Friday, it'll be late. So if like Friday passes but you don't think I'm going to start grading until Saturday afternoon, it's fine. Just make sure you get it in before I start grading. There will be a 5% penalty per day late, so when something's like 3 weeks late, it's not actually worth any credit. So make sure to stay on top of the open-endeds. The WebWalk, since it's all automatically graded, I'm less concerned about you falling behind. Try to keep up with it, but if you can make like 80% on the WebWalks by the time they're due, you can make up those extra 20 percentage points at any time. I do have deadlines in Canvas, but it's not like you can't do them late. There would be like a little red flag that I see if you complete a WebWalk late, but I don't care about that red flag. There will be some suggested problems, it'll be fine. There will be some quizzes, we'll get to them when they show up. I think that's enough of that. Any logistical questions about homework or exams? Really, no one's going to ask if calculators are allowed on the exams? Usually someone does. All right.
Calculators allowed on the exam?
Some of them. On like the first couple exams, there are some things that I really want you to do by hand. So either there will be a calculator allowed on like half of those exams, like there will be 2 parts, or not at all. But once we get past that point, I'll be fine with you using a calculator. How about note sheets? People want to know about note sheets? Yeah. Generally on exams, I allow a sheet of paper for notes. You can use both sides, you'll turn it in at the end, and I'll never give the note sheet back to you. If you want to keep your note sheet, make it twice. Cool. Attendance, I don't grade based on attendance, but you should attend. It's hard to pass a class if you don't take the class. Late walk, if you anticipate some stuff being late, like I'm a human being, I'm willing to like extend grace if there's like a reason that you're going to turn in something late, just let me know in advance. If you want to meet with me, I've got my office hours. You can set appointments. You can try just coming by my office. I might not be there, or I might be like very busy with something urgent and tell you I can't talk to you right now. But you can try. A thing that's not in this list is up on the 5th floor, there's a designated room called the Math Seminar Room, which is just a really nice space to walk on mathematics. And there's the advantage that if you just happen to be in the Math Seminar Room, my office is down the hallway. So if you're walking on stuff and you want to talk to someone, I'm probably available. Accommodation, if you have either SSD office accommodation or you have English as a second language based accommodations, let me know before the first exam probably, because you probably want to get that accommodation in. And there's like some annoying paperwork that you need to do with the actual SSD office or the languages office, which takes a little bit of time. So if you think you should want those accommodations, get them sooner rather than later. There are some resources that are available, well, more than these available to students on campus, but there's some things I want to point out in particular. There is the math tutoring lab in Centennial. Has anyone already been to the math tutoring lab yet? Yeah, okay, cool. It's over in Centennial. It's in the room that's above the Einsteins. They've got a statue of a dog in front of their door. Head on in there, there'll be people to talk to. I don't know if they're open yet. I bet if you click on that link, which it is clickable in the online version, it'll tell you their hours and when they open. They might not be open yet. The SSD office is services for students with disabilities. You can contact them if you should get any special accommodations. Even if you break your arm midway through the semester and you find it really hard to write, that's an SSD accommodation issue. Yeah. Counseling services. If you find yourself in a situation where you need counseling, don't hesitate to take advantage of them. They're not bad. I've used their services in the past. If you find yourself experiencing food insecurity, there's UWEC Campus Harvest, the UWEC Campus Closet. Even if you have an interview and you need formal clothes and you don't want to you can't buy them, check them out. You can get some stuff through them. The affirmative action page, the Center for Awareness of Sexual Assault. Cool. Academic integrity, I'll let you read that at your leisure, but in summary, don't do things that are obviously cheating. You can talk to each other on the homeworks, but I want to be grading your work. I don't care if someone else can do the homework. I don't care if you can ask an AI how to solve the problems that I ask you to do. Do them yourself. Yeah. And the AIs are not reliable. They don't actually know anything. Right? They try to recognize strings of words and decide what words are responses to those strings of words. So you're taking a big risk if you're trusting them for anything. Classroom environment. If there are issues, I'll bring them up. Cool. Any logistical questions? All right, cool. Then I'm going to go over to this. Anyone come in after the notes were distributed and need a copy? Cool. Is there anyone in the room who would prefer to just have an electronic copy of that on their tablet or whatever to take notes on instead of the paper copy? Cool. You can get the notes online. If you navigate over to the course webpage, the notes are a single gigantic PDF right now, 200 pages. It'll get updated. But if you go and export up through all of Chapter 1, you'll have a copy that'll be the copy we'll be going through. Nice. So I will make note that I need one viewer copy of that printed. And a thing, as long as it's the start of the period-ish. All right. Oh, maybe here's another note. I'm recording my lectures. I'm going to post them to the course webpage not long after class happens. So if you ever miss a class, it's not a huge disaster. The recording is just what the doc cam sees. So it's super boring to watch online. And probably not, it's not going to capture anything I do on the board. But if you miss class, it's not a disaster. You can catch up that way. If you do find that I do something that you didn't follow, you can come back through and skip to that bit in the online lecture. Take a look. All right. So, yeah, about 20 minutes, that sounds right. So let's start by just remembering stuff from the syllabus. This is worth maybe even making you grab right now. So I never know the office hours for my own classes. I I have alarms built in, and there are times that I just make sure I'm in my office anyway. But when are my office hours? Yeah.
Monday, Wednesday, and Friday from 1 to 2, and Thursday from 10 to 11 p.m. Or like 10 to 10:50.
Oh yeah, and I do actually have an obligation right at 11, so I can't be in the office right all the way till 11. Tell me about homework deadlines. Yeah.
Friday.
They'll be Fridays. And I'm going to make one other note. So it's going to be Friday the week after it's assigned. So on any homework, oh god damn it. This is something I'll do a lot. I'm supposed to be writing on things so that you can see them. And when I don't do that, stop me. Did I already swear in this class?
Yep.
Yeah, well, it's good to start on the right tone. That is not relevant. There are no. Tell me about the midterms. How many exams are there in this class? By some count. There will be like 3 honest-to-God midterms. There will be a lower weight background exam, and there will be a final exam. And you know what? So there will be a low weight background exam. And you know what? Let's also pull up the date for that, because that's like soon enough that maybe you should already have it in your mind. So here's the course webpage. It's got a day-by-day schedule. There it is. On Friday, September 20, I'll be giving this background quiz, which will have roughly half the weight of a midterm. The topics will be the things that we covered before it. Other than that, there will be 3 honest midterms. That's okay, that's close enough to spelled correctly. And there will be a final exam. So let's see, how many people are planning on using to look up their final exam schedule, this like lookup grid that says when does your class meet, as a consequence here is the time that your final exam will be. That does not apply to this class. So since there are multiple sections of this same class, and they all use the same final exam, all those classes have their final exam at the same time. So it's what's called a common final exam. Those don't get published until later on. To look up the exam time of this class when it's decided, check camps. It's not posted yet, but it will be at some point. And in fact, you'll probably know when the final exam is before I do, because I don't tend to check camps that often. All right. So let's start talking about what pre-calculus is, like what's going to be covered in this class. So the name of the class kind of tells you what it's going to be. This is the material that you need to follow what will happen in a study of calculus. I know a lot of people come into this class like having seen some calculus in high school, so let's see, how many people have some calculus background? Oh, cool. What's like, tell me some words that are important in calculus. Yeah. Derivatives. So basically half of the concept of calculus relates to this thing called a derivative. And the idea of a derivative, well, let's do like the graphical thing. So if you go and sketch the graph of a function, the derivative asks the question, what is that slope? How do you compute it? Once you can compute it, what does it tell you? And you can think of this as being, like, there's like a graphical way of thinking of it. But if you know the position of some object that's moving, can you get its velocity? That's what this derivative operator does. The other half of calculus turns out to be the exact opposite. So differential calculus studies the derivative, integral calculus studies the integral. And the integral asks a question that seems, at a glance, unrelated. If you graph some function, what's the area underneath that function? Can you compute it? What does it tell you? What does it have to do with the derivative? It turns out it has an awful lot to do with the derivative. And the place it's easiest to make sense of this. So imagine you know the speed that something's traveling at every moment of time. Well, if you add up like the speed at every moment of time, you should be able to recover the position, right? Or at least the distance it's traveled. And all that stuff that I just did is not part of the content of this class, but those are the types of things you do in calculus. Those are the objects you study. But in order to make sense of them, you need a bunch of tools before you can even start. You need to be able to think about graphs of functions. That means you need to be able to think about functions. So you better be able to make sense of like points in the plane, things like that. And a lot of calculus is going to be built on the back of having a broad swath of functions to apply calculus to, that you already understand the analysis and algebra of. I'm going to start having to build those. So now let's actually talk about the overview of what we're going to do in this class. So we're going to start with a bunch of things that will probably fit as background for most people. We'll talk about things like the number line, intervals, distance, the absolute value function. This is basically going to be today and some of tomorrow. We'll move on to this idea of how can you just study functions and extract relevant information out of them, which I guess graphically the derivative and integral try to do that in particular ways. Once we have this general language of functions, we'll start thinking about particular functions. We'll start by thinking about polynomials, which if you like are the easiest functions to make sense of. They're things that you can get just by doing some algebra. We'll start working on exponential and logarithmic functions. And if you like, that will get us like halfway through the semester. I think there's like a sub-bullet point on those exponentials. Yeah. So what are exponentials and logarithms? They're the things you need to do to model things whose growth rates are proportional to how big they are. So things like populations, right? The more rabbits you have, the larger the next generation of rabbits will be. They grow exponentially. Radioactive decay, compound interest, all those behave exponentially. The second half of the class will be all about trigonometry. I don't know. So at this point now, a thing to ask yourself is if all the stuff I said was going to be the first half of this class sounds like things that you know really, really well, then you might be well suited to getting into the trigonometry class, just jumping straight to the second half. Cool. I'm not saying anyone in particular should, but maybe think about it. All right, so those are the things we're going to do during the course of the semester. Let's start in, and there's going to be a bunch of background, so a bunch of this stuff will be things that you're already pretty familiar with, but I want to build up the language really formally from scratch. So let's just start with an interval. If I say I want to study the interval from 2 to 7, what does that mean? Yeah.
All the numbers from 2 to the 7.
Yeah, perfect. It's just all the numbers in between 2 and 7. And now I'm going to replace those with a and b. So the interval from a number a to a number b is just all numbers in between the number a and the number b. So if you like, there's a, there's b. This is what I mean by the interval from a to b. People feel pretty good? Well, you shouldn't. This definition is nonsense. It's ambiguous at least. And in order to think about why, let's, in the margin, is 5 in the interval from 2 to 5. Is 5 in between 2 and 5? And think on that for a second. Let's see, how many people want the answer to be yes? How many people want the answer to be no? More one said than I was expecting. There's no way to decide. There's not enough information. Between is ambiguous. I don't know whether to include the endpoints. So to fix that, there isn't just the interval from A to B. There are 4 different intervals from A to B, depending on whether you want to include or exclude the endpoints. And we'll indicate the difference by either including brackets or parentheses at the endpoints. If I say bracket A, B, I mean all numbers in between A and B, including A and including B. So I'll use brackets when I want to include endpoints, and the picture of this, well, if there's A, I'll put a solid dot to indicate A should be included, a solid dot to indicate B should be included, and then I'll shade the numbers in between. So brackets indicate you include endpoints, solid dots on the picture mean that those endpoints are included. All right, so let's see how we feel about intuition. So if brackets at each endpoint mean the endpoints are included, what do you figure parentheses is probably going to mean? Exclude them. There's A, there's B. I would like to exclude A, so I'll emphasize things are being excluded with open circles. So there's a picture of the interval from A to B excluding both endpoints. And then in between, maybe you want to include the right endpoint but exclude the left. Just include a bracket at the endpoint you want included. Parentheses is the one you want excluded. Feel pretty okay? Nice. And hopefully familiar. This is all supposed to be a review today. So, in order to decide if this is in fact ambiguous or not, let's answer some yes-no questions. Consider that interval from -3 to 1. So here are just some yes-no questions. Go ahead and answer them real quick. We'll come together in a moment. Ooh, and things that we do in class like this. It's not a test or anything. If you want to look at your neighbor's answer, or even just discuss it with them, you can. I'll be mad if you do that on an exam, but go ahead and compare with people around you. It's nice to get in that habit. All right, so first one, yes or no? Or maybe. Yes. So show of hands, this first one. Yes? Cool, I think I agree. -3, yes? No? Cool, I agree. Four. Well, this time I just want someone to say yes or no.
No.
Cool. 1.
Yes.
Awesome. Yeah, cool. You know what intervals are. So right now, a description of intervals is very much like a graphical thing. It's a little subset of the real line. You decide whether you want endpoints included or excluded. Gesundheit. But it's also really analytical in that this notion of betweenness can be modeled via inequalities. If you want the interval from A to B, you want all the numbers that are to the right of A, so that are bigger than A, and to the left of B, so less than B. So if you want to describe an interval via an inequality with a variable x, the interval from A to B with parentheses is given by A less than x less than B. Feel pretty good? How do you think that should change to get to, there's the closed bracket? So I need to be able to include the endpoints. Yeah.
A line underneath it?
Yeah, if you draw a line under a less than, it becomes a less than or equal to. Because right now, if you list the endpoint, A is less than or equal to A, and A is less than or equal to B, so A satisfies those. And if you want one bracket but not the other, you can do that too. Feel pretty good? Nice. Let's do some algebra with inequalities. And again, a bunch of this is going to feel a lot like a review. There's a single, like, has-on the way here. There's an inequality. Does that look like an inequality you can solve? I'll see how people feel. I can go through, or I can just be quiet for a bit and let you do it, and then we come together. People feel like they want me to keep talking right now? Cool, I won't. Go and solve that inequality. And you can talk to each other if you want. And even if you feel like quite confident in your answer, discuss it with the person next to you. We'll come together in a moment. Just want to make sure everyone feels pretty good before we do. Cool. What's the answer? I didn't walk it out. People sounded confident. Yeah. -1 greater than x greater than equal to -3. Do I hear a second? Do I hear a contrary answer? Do I hear disagreement? Okay, but do I hear agreement? Okay, cool. Should we talk through it? Cool, let's do it. So, and there's even like step-by-step things. Let's do it. So, here's the inequality you want to solve. So really, what does that mean? You want to get like x on its own. So let's take that and get x on its own. What seems like a good first step to do that?
Add 4, well, 4x.
Add 4x. It's not wrong. I'd rather leave x alone for now and deal with that last. Well, you know what? We can do this. Yeah, let's do it both ways. So add 4x to everything in sight. 6 plus 4x less than 2 less than or equal to 14 plus 2x, like that. 4x. All right. What would you like to do next? And so here's why I felt off about this. I've gone from a state where there's only one x in sight to 2 of them. So it's not that this is a long move, but I think it has made, in some ways, the problem more complicated instead of less. So instead, let's take the one thing that has x's in it. Let's try to make it so that that piece is just x on its own. So instead of dealing with the 4x, let's deal with that 2. How do you get rid of that 2? Subtract 2. And what you did wasn't wrong. It was just, and there was a path that would go from there, but I think it would be more complicated. It wouldn't be undoable. So subtract 2 from everything in sight. 6 minus 2 is 4, less than negative 4x, less than or equal to, 14 minus 2 is 12. All right, what next? Yeah. Divide by negative 4. And I'm going to do something wrong now. Let's divide everything in sight by negative 4. So let's see, 4 divided by negative 4 is negative 1, less than x, less than or equal to 12 divided by negative 4 is negative 3. I said something's wrong there. What did I do wrong? Yeah.
You have to flip the sides around.
Yeah, right. So negatives do interesting things to inequalities. When you multiply something by negative 1, being on the right becomes being on the left. So inequalities flip when you divide by a negative sign. So there's a straight up error there. The correct thing is on the next page. So divide everything inside by negative 4. When you divide by a negative sign, you flip inequalities. So let's list that. So it becomes negative 1 bigger than x, bigger than or equal to negative 3. Does that agree with the answer that we had on the previous page? Awesome. There's one comment I'll make. This is perfectly fine as an answer you give to a person, but if I were expecting an answer in this order, it's not. So let's just put it in the right order. WebWalk will be picky about these things. Feel pretty okay? All right. What interval is that? I'll give you this much anyway. It's the interval from negative 3 to negative 1. How should I decorate the endpoints?
Bracket on negative 3, parentheses on negative 4.
Awesome. Cool. I'm happy. There's 2 more kinds of intervals. There's half infinite intervals, and then I guess the infinite unbounded interval on both sides. Let's just list those. Let's just see what you think it should mean. The interval from a to infinity with a bracket at a, what should that mean? In words, as an inequality, as a picture, whatever. Well, I'll list one thing anyway. So, if you go back to these notions, that interval looks kind of like this. Let's just write that with an infinity. So that'll be a less than or equal to x less than infinity. Of course, so here's the catch, infinity is not a number. It's an abstract symbol at best. But what you should think of it as meaning is infinity is supposed to be a thing that's bigger than any number. So saying x is less than infinity doesn't actually mean anything. So you don't need to write it. Oh, I have erasable pens. I'll use those a lot. So hopefully that doesn't screw up too many people when they take notes. The interval from a to infinity is just all numbers that are at least as big as a. Yeah.
Is the other version a valid answer?
Yeah, but if you like put is less than infinity, I'll circle it and say you don't need to include this. It's silly too, you're wasting space. Everything's less than infinity. And depending on the notions you do in mathematics, once you get to theories of cardinality or set theory, then less than infinity can mean something really weird because it turns out there's lots of different things that you could mean by infinity. But we won't get to that issue. So it's not long in this class, but it'll feel a little bit, off. And pictorially, you know what that means too. If there's a, let's put a solid dot at a, it should be included. And then I want to include everything to the right. Everything that is at least as big as a. Do you think you could now decide what the rest of those symbols should mean on your own? Yeah, right. If there's a parentheses, make that less than or equal to or strictly less than. If a is the bigger endpoint, then the inequality goes the other way. Draw open circles when you want to exclude. And I guess, so here's the thing to note. Those infinities always have parentheses next to them, right? Since infinity isn't a number, in this class anyway, I will never talk about including infinity in an interval. It's not a number, so I'll never include it in an interval. Whenever you see an infinity, I'll never put a bracket next to it in this class. You can try to make sense of what it should mean to include infinity in an interval, but we won't. You have to, it's just not something. Nice. Feeling pretty good? Groovy. Last thing I want to hit with today, I have 3 minutes. It's not enough time to do everything I want today, but we can do just a little bit more. Yeah, let's talk about absolute values. And to start by just telling you already know what absolute values should mean. Let's just fill out this table. Absolute value of 5 is?
5.
Absolute value of -5 is?
5.
Cool. So you have an idea already, absolute value wants to throw out the negative sign. Absolute value negative pi. Absolute value 3 minus 6.
3.
3, right? And how do you get that? Well, you evaluate from the inside out. 3 minus 6 is -3. Absolute value is going to throw out that negative sign. Skip that. Absolute value of 0.
0, 0.
Nice. So, those things that we just did, that's enough to decide what absolute value should mean. I think my eventual goal with my remaining 2 minutes is basically to get to this. So, answer these questions. So if I tell you that a number of x is already positive, what is the absolute value of x? Let's just start listing some positive numbers. What's the absolute value of 1? Absolute value of pi? Absolute value of 17?
17.
If x is positive, then the absolute value of x is x. Yeah. Absolute value just returns that same number again if you know that that number is positive. If x is 0, then what is the absolute value of x?
0.
Yeah, cool. X is already 0, so I'm just asking you the absolute value of 0. Well, there's one other type of number. There are positive numbers, there's 0, and there's negative numbers. When x is negative, how do you get the absolute value of x? Let's see, what's something you can do to take a negative number and make it positive? Yeah. Multiply by -1. Yeah, give me a couple minutes. So, if you have a number that's already negative, you can get the absolute value by multiplying by a negative, or just writing negative x, right? That means the same thing. So, that gives me what's called a piecewise formula for absolute value. If you want to compute the absolute value of x, if x is positive, we're on x. If x is 0, we're on 0. If x is negative, we're on negative x. And what will we do on the next page? We'll use that to make some computations by making this sort of decision. And no, definitely not enough time to do it right now. So this is where we'll stop for now. We'll pick up right here tomorrow, right? This class meets Thursdays? Good. Oh, I have an office hour today. Anyone planning on coming by? Okay. I'll be there anyway. And hopefully today felt very light to everyone.
I don't have another class.
The intent is to start fairly gently. Yeah.
I got up early to go have some. I got there so what do you
Yeah, as long as you can explain what you're doing. Yeah, there's more than one way to do all of that. What sort of things felt particularly?
Are you walking up to your door? How long?
Oh, yeah, that makes sense.
I'll head up to.
Oh, so you like splitting your quality?
Yeah.
Yeah, that's a good move to make. These ones are simple enough that you don't need to do that, but yeah, a lot of times, yeah, just solve each inequality one at a time. Oh, yeah, it's yours. Say that right? Yeah, that's not a bad idea. Because I will, like, this is going to last us for a week, a couple weeks, and then I'll hand out more notes. Yeah, I do hold on to put that with you. Yeah, so it's an appendix section, in fact, at the back of the book. Yeah, so it's like in this area, yeah. So this is like A1. I think that I'll hand this back to you. The suggested problems are like from A1 and A10. Yeah. And